Hello and welcome to the task bump mapping. This time we are using textures again, but instead of conveying the color of the fragments, we are conveying bumpiness or height of that fragment. So what we want to do is we want to change the normal vector by giving it a bump map. So a bump map is just a texture with different height values. And in the fragment shader, we are going to use these different heights to change the normal. So you can see that we calculate the derivative of this location, and then we are going to use the normal on that sloped surface instead of a regular normal, which is just up. And the end result should look something like this. You can see that there are different bumps, and since the light location is here, you can see that it's lit from here in this location, but lit from here in this location. So it gives this illusion of 3D texturing, but actually it's just a 2D plane. And yeah, there are different examples. We have these bumps or cavities, and we also have a brick wall. So if we use this brick wall bump map with brick wall texture together, we get this really realistic brick wall where those gaps here are shaded correctly. Most of the work is done in the fragment shader, and nothing is in vertex shader, I think. But there is one thing in the C++ code as well, namely this place here in the draw scene. We want to rotate this plane. So currently if I run the code, I can see this red box here with the light source as well. But I wanted this red square here to rotate. So you can see here, this is a bit rotated, right? And this is also a bit rotated. So I want this to rotate between minus 45 degrees and 45 degrees. So that's what has to be done in the main loop. You can also see that the light position here is still not defined, and in the last step of the texture, the fragment shader, we actually add this Phong or Blinn lighting model here. That's where we use the light position. But that's the last step. So right now we can just comment this out so it doesn't interfere with our tutorial. But yeah, let's see what has to be done here. So it's quite a big wall of text here. We have two textures here. We have the texture for the color, and we also have texture for the bump. And we have all these detailed steps here. So the find gradient vector. We use our plane is locally located at the xy plane. This means that the local coordinate z is 0. Construct a normal shift. We want to affect the surface because you can actually see that this texture is here deformed where the bumps are happening. But yeah, we can start from the beginning. I won't do everything here. You have to do most of the work, but I will give you first few steps. So let's find the gradient vector. So first we have to create a small step size. So if we go back here, we can see that the step size here, if you use the central difference, is 2 pixels. But in fragment shader, we don't have pixels. We have just sizes. So we can define it as 0.001 or 0.01. This can't be too big, but can't also be too small. It has to be bigger than pixel size, but small enough that it's the size stays like a local location. So the step size, let's for now set it to 0.001. And you can experiment with different sizes to see which one looks the best. Then we have a sample from one step size from the right of the current UV coordinate, subtract from the sample one step size to the left. So that's the U coordinate. Let's define it. So this vec2 gradient, and that's a big definition here. So vec2. So let's separate it onto the two different lines, and can actually zoom in as well. So what we want to do is sample from one step size from the right of the current UV coordinate. So it should be texture 2D, and we use the bump texture here. And what's the coordinate? We use the interpolated UV. So that's that one here. And we want this to be one step size to the right. So what's the right? That's the positive first coordinate. So vec2 step size. And that should be 0 because we don't want to affect the v coordinate. And now we want to subtract the left step from it. So let's put the subtraction sign here. So let's subtract from here, and I will put it on a separate line again. And exactly the same bump texture. But now we don't want to add this. We want to subtract it. So that should be the u coordinate of the gradient. And we can do exactly the same thing, but instead of using the u coordinate, we use the v coordinate. So now we have to switch these around. Step size and 0, and here exactly the same, 0 here, and step size here. Let's see what is the problem. Type. Aha, okay, so this returns a color, which is a 4-dimensional vector, but we also only want to use the first channel, so let's use the error R for this. So now the subtractions work. Let's remove the last comma, and let's see what is. Oh, there is also bracket error. Okay, looks like it works. And now we want to see what it looks like. So I'll just temporarily put it here as the first two coordinates. And if I run it, let's see what it looks like. So it looks like this very noisy texture, but if we use different bump textures, you can actually see this brick color here. So changing this step size gives different results. For example, if we have 0.1, we can actually see this noisy, which was noisy is like less grainy. And also this second one, the bump 1, which is this bump texture here, is also visible now. So if I had this as 0.01 now and change it, I can see that it's a lot more subtle. So that's why this step size works. And this step size is not like one size fits all. Different textures want different step sizes. For example, I can definitely see that step size 0.1 is very strong for this second one, but not very good for the other ones. For example, yeah, the brick one looks very strange. Like you can see the shadow here is the one gap here and the other gap here. This does not look correct. So for the brick wall, the smaller step size looks better. But yeah, let's analyze this. So we can take the bump map here and see what does the gradient look like. So remember, the red is the u coordinate of the gradient and green is the v coordinate. So we can see that if the u coordinate goes from black to white, we can see that it is red. So this is from this location and from this location, which means that the gradient is rising. This gradient is positive here. And there's also a negative gradient here at this location, but we don't see it because it's below 0. And exactly the same for the v coordinate. We can see that if we go from the bottom to the top, the positive gradient is green here. So when we go from black to white, it's positive gradient, so it's green. And there should also be a negative gradient here. So actually we can visualize negative gradient if we just negate this here. And yeah, now we can see the negative gradient as well. So if we go from white to black on the v axis, it's green. And if we go from white to black on the u axis, it's red. So that's the gradient map. And we can use this to change our normals. And let's see how we can use this to change our normals. So we have completed the first task or the first step of the task, which is to construct the vec2 gradient based on the finite differences just found. The second thing is our plane is locally located. So we want to do this normal shift. And normal shift is how much should the normal shift? And we can actually define it as well. So because normals are 3D vectors, we want the normal shift to also be 3D vector. So normal shift. And this is just first two arguments are gradient and the third argument is 0. Yep. Oh, that's not how to write GLSL, that's how to write it. Okay, so now the normal shift can be used to calculate the shift the normal. And to be autocorrect, you should multiply that normal shift vector with normal matrix. So you have to later multiply the normal matrix as well. And then shift it and normalize the normal as well. Don't forget to normalize the normal after you have transformed the normal. And then there's a third step if you want the effect to be deformed. And in the third step, we want to deform the texture as well. So if we look more closely to this picture here, we can see that we have this grid line here, which is, can actually see what's this texture. So it's the stripe texture, I think, no, lines. So we are using the lines texture here, but when we have these bumps here, those lines are not straight anymore. And this gives a more convincing illusion that there's actually a 3D geometry change here. So we use the normal shift vector here as well. Yeah, one simple way to do this is add a small factor of the normal shift xy. So this is this that we just defined. And this one has to be in local space, not in I space. So don't use the version that you multiplied with normal vector. You can also use the gradient here. So you can just replace this normal shift xy with gradient, and that's also correct. And yeah, you can of course experiment with different factors. So you can try with 0.05, for example, and see what looks the best.